Hello everyone, this is Ramachandran, math tutor from Online Math for All. In this video, we are going to see some Desmos tricks to solve math problems in SAT. Okay, let's go to the problems. A square pyramid has a volume of 400 cubic inches and a slant height of 13 inches. If each side of the square base and height are integers in inches, what is the surface area of the pyramid in square inches? Okay, first let me take a square pyramid. Here we have a square pyramid and the base is a square, so all the four sides are equal in length. Let me assume x as a length of each side of the base, and the value of x is an integer according to the information we have over here. And let me assume y as the height of the pyramid. This y also is an integer according to this information. And we have the slant height that is 13 inches. So the line segment we have over here represents the slant height. So its length is 13 inches. Okay, now our aim is to find the surface area of the pyramid. Surface area means the total surface area. There is a formula to get the surface area of a pyramid. There is 1/2 times P times S positive B. This P gives the perimeter of the base, and this S is the slant height. We have the value for this S, that is 13, and this capital B gives the area of the base, that is the area of the square base we have over here. Okay, now to get the perimeter of the base, that is this P, and the area of the base, capital B, we need the value of x, that is the length of each side of the square base. How do you have to get the value of x? Let me consider the volume of the pyramid given over here, that is V equals to 400, and we have formula to get volume of a pyramid, that is 1/3 times base area times height equals to 400. Okay, now to get the area of the base, we have to use a formula to get area of a square, that is side times side, x times x, that is x square. So 1/3 times x square is base area times the height is given by y equals to 400. Here I got an equation in terms of the two variables x and y. Now let's consider the right triangle we have over here. In this right triangle, this is a hypotenuse. The slant height is a hypotenuse because it is opposite to the right angle, and this one and this one are the two legs. Okay, now to get the length of this leg, we have to consider half of the length of the side of the square, that is half of this x. So the length of this leg of this right triangle is x/2. Already we have the length of this leg y. Now we can use a Pythagorean theorem in this right triangle. That is sum of the squares of two legs equals to the square of the hypotenuse. That is x/2 the whole square positive y square. Sum of the squares of two legs, it is equal to the square of the hypotenuse, 13 square. Now we have two equations in terms of x and y. We can use Desmos to solve for x, which gives the length of each side of the square base. Okay, now let me give the first equation. I mean this equation as input in Desmos. Let me do it. That is 1/3 times x square times y equals to 400. Now let me take the second equation as input. That is x divided by 2 the whole square positive y square equals to 13 square. Okay, now I got graphs for both the equations, and as I said already, our aim is to get the value of x, which gives the length of each side of the square base. Now to get the value of x, we have to consider the points of intersection of the two graphs given by this equation. Okay, now let me consider the points of intersection of the two graphs. Here we have a point of intersection, and here we have a point of intersection. Here we have, and here we have. Okay, there is an information that is the each side of the square base and the height are integers, and both x and y values must be positive because x is the length of each side of the square. It cannot be negative. Always it has to be positive, and y is the height of the pyramid, so that one also cannot be negative. So now in these 4 points of intersection, we have to consider the point of intersection where we have both x coordinate and y coordinate are positive integers. So that is over here 10, 12. So at this point of intersection, both the x coordinate and y coordinate are positive integers. So what is the x coordinate? That is 10. So that's the value of x over here. That is 10 is the length of each side of the square base. Okay, now we can start finding surface area of the square pyramid. That is s equals to 1/2 times. Already we know that this p gives the perimeter of the square base. Okay, here the length of each side of the square base is 10, Now to get the perimeter of this square base, we have to add the lengths of all the four sides. That is 4 times 10 is 40. And we know that S is a slanted, that is 13 positive. And this capital B is the area of the square base. To get the area of the square base, we have to multiply the side by side. 10 times 10, that is 100. Okay, here 2 goes into 2, 1 times 2 goes into 40, 20 times S equals to, when I multiply this 1, 20 and 13, I am getting 260 positive 100. I don't use Desmos to do simple calculation. Okay, S equals to, when I add 260 and 100, I am getting 360. That is square inches. Okay, here I got the surface area of the pyramid, that is 360 square inches. In the xy plane, the graph of x square positive 6x positive y square positive 2y equals to 15 is a circle. Line K is a tangent to this circle at the point A comma B and has a slope of 3/4. What is the possible value of B? Okay, A comma B is a point of tangency and this 3/4 is the slope of the tangent line K. Okay, using this slope, we can write the equation of line K in slope intercept form, that is y equals to mx positive b. For m, that is for slope, we have 3/4. So we can write 3/4 x positive b. Now let's give these two equations in Desmos as input to get the graphs. Okay, first let me type the equation of circle, that is x square positive 6x positive y square positive 2y equals to 15, and the equation of line K is y equals to 3/4 x positive b. Okay, now let me zoom out. Here, let's click on B to get the slider to adjust the values for B. Here we have the line K. According to the information, line K is tangent to the circle. But now the line K over here is not tangent to the circle. So we have to adjust the value of B in the slider over here to make the line tangent to the circle. Okay, now let me move the value of B to the left side so that it can become tangent. Okay, here now the line has become tangent to the circle and the point of tangency is 0, -5. But the question says the point of tangency is A, B. When I compare these 2 points, at the place of B we have -5. So from this one we get a value for B, that is B equals to -5. And we can move the line K as a tangent to the other side of the circle. So for that we have to adjust the value of B. Okay, now let me adjust the value of B over here. Just a moment. Okay, now so the line K becomes a tangent to the circle on the other side. Okay, now the point of tangency is -6, 3. When I compare this one with A, B, at the place of B we have 3. Okay, here I get B equals to 3. So our aim is to get a possible value of B. A possible value of B is either -5 or 3. A is 540% more than B and B is 0.02% of C. If A is K% of C, then what must K equal to? So that is we have to find the value of K. Now let me consider the first information, that is A is 540% more than B. We can write this information as an equation, that is A equals to, since we have 540% more than, we have to add this 540 to 100, then we get to 100 positive 540 percentage of the quantity we have over here, that is B. For that we can write the same equation as when I add 100 and 540, I am getting 640, that is 640% of B. I got the first equation using the first information. Now let's write the second equation using the second information. That is B means B equals to 0.02% of C. Now let's consider this one, that is A equals to K% of C. Further, we can use Desmos to find the value of K. Now let me consider the quantities we have on the left side of all the three equations, A, B, A. Okay, now let me give these three quantities as input over here in Desmos. Let's take square bracket A, comma B, comma A, close the square bracket. Now we have to take the tilde sign, again take square bracket. Now let's consider the quantities we have on the right side of all the three equations. Okay, in the first equation we have 640% of B, comma, the second equation we have 0.02% of C. In the third equation we have K% of C, close the square bracket. Okay, here I got the value of k, that is the value of k equals to 0.128. We have an equation. In the equation above, a, b, c and d are constants. What is the value of a positive, b positive, c? We can use Desmos to solve this problem. Let's define two functions f of x and g of x so that f of x equals to the stuff we have on the left side of the given equation and g of x equals to the stuff we have on the right side of the given equation. Then the above equation will become f of x equals to g of x. Now let's consider some value for x, say x equals to k. When we have x equals to k, then this equation will become f of k equals to g of k. So that is, I plugged in this k for x over here and here. Okay, now let me give the first function f of x as input in Desmos. Okay, let me type the first function. That is f of x equals to a x to the third power positive, b x to the second power positive, cx positive d, and it has to be divided by x square negative 9 times x positive 2. Okay, now let's give the function g of x as input. That is g of x equals to 5 divided by x positive 3 positive 6x divided by x negative 3. Okay, now let me give this equation as input. When I give this equation as input in Desmos, instead of equal sign, I have to use a tilde sign. So this is tilde sign. Okay, now let me give this equation as input. That is f of k, then tilde sign, g of k. And we know that k is the value of x. Since the function f of x contains four unknown constants a, b, c and d, now we have to assign four different values for k. Okay, now let me assign four different values for k. That is k equals to square bracket 1, 2, and we don't want to take the value 3 for k because we know that k is the value of x, and when I take 3 for k, that's the value for x. So when x equals to 3, the denominator here will become 0 and this fraction will become undefined. So we can avoid taking 3 for k, and instead of that we can take some other value. Already we have taken 1 and 2. Now let's take 4, then 5. Okay, here I got the values of a, b, c and d. A is 6, b is 35, c is 31 and d is negative 30. And our aim is to get the value of a positive, b positive, c. Okay, now let me get the value of a positive, b positive, c using Desmos. That is a positive, b positive, c. Okay, here I got the value of a positive, b positive, c, that is 72. G of x is a quadratic function. In the xy plane, the graph of y equals to g of x passes to the points 12, 540 and 16, 908. If g of 0 equals to 12, what is the value of g of 24? Okay, let me write the given quadratic function g of x in standard form. That is g of x equals to ax square positive bx positive c. Now to evaluate the value of g of 24, we need to know the values of the three constants a, b and c. Since there are three unknown constants in the quadratic function g of x, we need 3 points on the graph of the function g of x to get the values of these constants in Desmos. But here in the given information, we have 2 points. One is over here and the other one is over here. So we need the third point so that we'll be able to get the three unknown constants a, b and c. We can get the third point from this information. We know that y equals to g of x. So this g of 0 represents a value of y when x equals to 0. So we can write this one as a point. That is when x equals to 0, the value of y is 12. Now let's give these 3 points as input in Desmos. Okay, let's click on this positive sign and click on table. Let me give the first point as input. That is 12, 540. Then the second point is 16, 908. And the third point is 0, 12. Okay, now we have to give this function as input. When I give this function as input, instead of g of x, I have to use y1 because here we have y1 for y. So we have to take y1, and instead of equal sign, we have to take a tilde sign. A times for x, we have to use this x1. That is x1 square positive b times x1 positive c. Now we have to give the function as input, this one. Okay, here let me type that is y1 tilde sign, then a times x1, that is x1 square positive b times x1 positive c. Okay, here I got the values of the three constants a, b and c. A is 3, b is 8 and c equals to 12. Okay, now let me rewrite the function g of x as that is g of x equals to, for a we have 3, that is 3x square, and for b we have 8, that is 8x, and for c we have 12. Okay, our aim is to find the value of g of 24, that is we have to plug in this 24 for x over here, then we get g of 24 equals to 3 times 24 square positive 8 times 24 positive 12. G of 24 equals to, let's evaluate the value of this one using Desmos, that is 3 times 24 square. Let me type it, positive 8 times 24 positive 12. Okay, here I got the value 1932. That is g of 24 equals to 1932. Hello everyone. Hope you have understood all the Desmos tricks explained so far to solve math problems in SAT. Thanks for watching.